Well, hello again everybody and welcome back to this Hallicrafter S20-R restoration. Now, thanks very much for everybody that decided to leave a comment in the last video, because I did ask you what I thought you should do with this radio, and I've got to admit, I was quite surprised by the outcome. I thought you would all want to torture me by seeing this thing restored. I thought that everybody was going to be in favour of restoring this radio, but a lot of you, I think, have very sensibly said that, well, this radio is in such a state that it's really not worth bothering with. And I've got to admit, I actually kind of agree with that assumption. I think whatever we do to this radio, it will never be a great performer at the end of the day. I'm certainly very concerned about this band switch. It feels very crunchy, and there's something not quite right with it, but I've got to admit I can't work out what. I don't understand why. It seems to have too many positions. It's got too many indent points on it. So I'm wondering if at some point somebody's already had a go at repairing this switch and they've maybe installed something else. Now, I think most of the electronics on here I could repair, but this wafer switch could be a real problem because, well, the wafers are designed to operate in a certain manner, aren't they? And if they don't operate like that, you just can't go to the wafer shop and get easy replacements for them. So unless you've got a scrap set or something like that, these type of mechanical problems can be very difficult to overcome. So I think we do need to assess this switch and work out whether it's good or not, and I'm hoping we'll be able to do that today. Now, one of the other things that I'm going to be looking at today is the output transformer, or lack of. Now, when I actually got this radio, it actually had some wires coming out of the chassis right here like this, and I could see two wires and another two coming out from where the transformer was, and these wires were actually wired to the back of the speaker. So I actually logically assumed that this was an output transformer. It's not an output transformer, unfortunately, it's just a choke, and these wires were actually connected directly to the anode of the 6F6 output valve. Now, of course, an 8 ohm speaker isn't going to be a very good match for a 7,000 ohm anode of a 6F6 valve, so that was never going to work. So what I've done is I've actually ordered one of these replacement output transformers from RS Components, you know, one of the types that has multiple tappings on it, and what I thought we could do is we can try substitute that and see if we can make the radio function off its own audio. I do wonder if the valve might be damaged because of the way it was connected to the speaker. Maybe it's been red plating, I don't know, but certainly this valve was feeling very hot compared to all the others in circuit, so we may have a bad valve, I'm not sure. Well, off camera I've actually been quite busy with the old snippy snip, so there was actually a lot of wiring for things like there was a dial lamp which was in circuit, which was really horribly connected, so that was in the way, so we went snippy snip. I've cut that off. There was also this headphone socket which was in circuit. It was in circuit with this well, you can see this cotton covered wires, and somebody had just soldered this single core very thinly insulated wire to it. They hadn't even bothered to actually insulate the joint, so this was shorting out. One side of it was connected to the HV supply, the B+, so that wasn't very good. So that's just snipped out because, again, couldn't see the wood for the trees. There's also a standby switch here which was connected to one side of the live supply, but the other wire was just dangling free inside the set, just waiting for me to put my hand in there and get a belt. So I went snippy snip, and I've cut that back, and I think the next thing that I'm going to start to do is I'm going to start to try to tackle this power supply arrangement. So I'm going to try and get rid of these big capacitors here, because again it comes back for I can't see the wood for the trees. These things are just in the way. I can't really see what's happening. There's a great big terminal strip here, which I was going to say it's installed in the bottom of the radio. I found out that this tag strip, I think it's completely loose. It's not actually bolted down to anything. It's only staying there because it's got so many wires actually soldered to it. So hopefully you can see that. This is completely loose at the moment. So this has got the incoming mains and the earth wire connected to it. It's also got a lot of other wires just I don't know, floating around it, all uninsulated. So that's all potentially at mains voltage, is a little bit of a mess. And then right adjacent to it, we've actually got the supplies, the high voltage B plus voltage coming back to the rectifier here, and we've got all the smoothing capacitors and stuff like that all going on in this area. But you can't see the wood for the trees, so I'm intending to actually cut some of this back until it becomes a little bit more obvious what's actually going on in here. So that's the first job that I think I'm going to tackle today. One of the first things I've spotted down here, we've got this capacitor here. Now I'm pretty sure that this capacitor here, I think it's the cathode bypass for the 6F6 output valve. So what I intend to do is I'm going to see if we can get that unsoldered and maybe replace it. Okay, so the wire that we've just unsoldered, I think that this probably originally went into the main smoothing electrolytic here, which was one of those, I don't know, capacitors. You know, it's got 3 capacitors in a single can. Don't know what you call that. What do you call that, 3 capacitors in a single can? I don't know, leave it in the comments. So I think it was probably, I think the actual cathode bypass capacitor could have actually been installed in the main smoothing can here in one of the terminals. I've got to admit I'm not completely sure. So I think what we'll do is, I can see that one of the wires is still going to that original smoothing can, but again, the problem is the circuit diagram, it isn't very clear. There's no chassis layout for all the components, and it just refers to that as electrolytic. It doesn't actually say which of the capacitors are within that electrolytic. But I think we need to get that off. Now at the moment these capacitors are in my way, so I think we need to let me just verify that that end is at ground. Which it is, so I think we need to have that off. Okay, that's good. Now we've got those components out the way, I can actually see the underside of the main smoothing capacitor, and I think I can see, oh, actually I can maybe see quite a few terminals on there. They've been bent over. I think I need to get that out next. Now while I've been working on this radio, not only have I found that many of the components have been badly replaced, the actual wiring is wrong. The way it's been put back together, they've got certain parts of the wiring being fed from the wrong side of the smoothing choke and from the wrong capacitors in the circuit. So it's either the circuit diagram that's wrong, or it's actually the radio that's wired wrong. I think it's actually been wired wrong. Right, okay, I was trying to undersolder that wire off that tag there, but I haven't been able to do that. Can you see that? We've just got terminals here which are just, well, they're just crushed and bent over, so yeah, it's not going to be very easy to get out this. You can also see that one of the tags holding the capacitor in has been soldered down. I'm not sure if my soldering iron has got enough thermal mass to release that, but we will try. Right, can I reach over and grab this capacitor? Now because there isn't a huge amount of room in this chassis to have these great big bodgy components in, if we possibly can, I think I would like to try to restuff this. There we go. Brute force over ignorance wins every time. So taking a look at this multi-capacitor that I've just removed, I'm just trying to see if I can see the manufacturer. Not sure that I can. It says, well, it says made in the USA, which I guess is not surprising. Now, I think actually this has got 4 different capacitors in it. Unfortunately, one of the legs has been bent, so it's a bit difficult to see. Makes me wonder if any of these capacitors are still good. Somebody's obviously previously has cut out the main smoothing capacitors and replaced it with these big ones in the back of the set here. So looking at this, it had a 30 microfarad at 450 volts, it had a 10 microfarad at 450 volts, it had a 10 at 400, and it had a 20 at 25 volts. So yeah, this had 4 capacitors inside it, but unfortunately the circuit diagram just actually shows this as being called the LEC, so you know, it doesn't actually pinpoint where any of those capacitors are. If anybody has any type of chassis layout for this radio, I'd appreciate if you get in touch with me. Maybe you've built one of these in the past and you made some notes. If you've got a proper annotated chassis layout, I'm trying to do one as we speak. But if you've got one, that would really help me a lot. So this is the one that I think I'm going to replace. I did think maybe I would restuff this. I'm not exactly sure what I'm going to do yet. I might have a look at how big the replacement capacitors would be, what we'd have to get in there. Gosh, for a minute, I was expecting some higher ESR values there. I think some of these, that's maybe the problem. It feels like some of these capacitors might have loose connections internally. Okay, yep. That one's coming up 15 ohms ESR now, so that's no good. And now it's gone back to 2 ohms. So yeah, maybe they're losing internal connections, but yeah, somebody decided to remove this in the past. I'm going to go along with their decision. Well, as you can see, I've actually gone ahead and I've melted all the insides out of our old capacitor, and I've actually restuffed it with some new capacitors. Now, it's not my finest work. It was actually quite difficult to get these capacitors in here because 2 of them, actually no, 3 of them are all rated at 450 volts, so they're quite sizable. So it was a little bit like playing Tetris, and yeah, I probably could have cut the can a bit neat, so I've done the best I could with it. It's not perfect, but it'll have to do. But once we have reinstalled this capacitor in its original position, it'll enable us to remove those horrible big capacitors. This one's still there that was strapped in there, and also one of the cathode bypass capacitors which was strapped down here as well. So it will actually release quite a lot of real estate within the chassis, and I think it'll look a lot neater, so it's worth doing. I've stuck our main electrolytic smoothing capacitor back in here. I've also gone ahead and a lot of the wires on this transformer were just falling off there. All the insulation was cracked and in a terrible way. Now unfortunately I couldn't rewire it properly because these wires actually go into the body of the transformer. So what I've actually done is, where the worst of the damage was to the insulation, I've cut the wires back and I've used some heat shrink and I've plumbed in some new wires. We seem to have a couple of leftover cables here, a couple of leftover wires. I think this little one here is I think this is a screen which wasn't connected on the transformer, and then I think maybe we've got a secondary here for actually powering up a rectifier valve which weren't used because the previous owner had replaced the rectifier valve with a solid state rectifier. Now it would be quite nice to put that solid state rectifier back, but one of the problems with this set is it actually has quite a high HT voltage, considerably more than what this transformer puts out. I think this one is something like 275 volts, whereas I've got a feeling the original transformer would have been in the region of 350 volts. So I'm hoping that although this transformer is going to be low in voltage, I'm hoping the fact that we've replaced the rectifier with a valve, with a solid state rectifier, I'm hoping that will help get the voltage level up slightly. But I think that this set is going to suffer from too low a B+ voltage. So in the future, if we can get it to work even a little bit, I'll be looking at taking this transformer out and replacing it with something a bit more suitable. But I think we're a long way from there yet, so we'll just twist these wires out the way and pretend we haven't seen them. What could possibly go wrong? Now I also had a bit more trouble here with this choke because I wanted to replace a wiring on it which was again crumbling and the insulation was in a poor state, but unfortunately as soon as I touched one of these wires it just fell off. It came off in my hand, as sometimes happens. So what I had to do is I had to cut a hole in the insulation and the wrapping of this choke to expose a new bit of the winding, which I then cut and broke out, and I've actually joined a new wire into here and glued it in with epoxy, and at the moment it's just got a bit of tape over it. But assuming this repair holds, I'll probably I'll put some gaffer tape or something, a piece of black tape over this just to tidy it up a bit. But it is functional, this choke, so that does work. Now I'm hoping you can see that a lot of the rubbish that was previously installed here has now been removed and actually been replaced with this single multi-segment capacitor which we've restuffed. You can see some of the wiring here is still a little bit untidy, and that's partly because I've dressed the cables off at one end, but I've actually left the other end a bit longer for all of these because I'm not sure on the final routing or if I'm happy with this yet. So I've left some of the wires a bit long, and when I am happy with it, we'll shorten them and terminate it properly. Now I'm afraid my work isn't the neatest work. Some people do a beautiful job of rewiring radio chassis and stuff like that. Maybe it's just a matter of practice, but I'm afraid I'm not very good at it. It always comes out a little bit untidy when I'm doing it. C'est la vie, I suppose. A lot of the old wiring, again, this old canvas covered wire, cloth covered wire, it just fell apart, so I've had to replace some of that. Now actually all the original capacitors, or the replaced capacitors I should say, they're still bodged into situ. I haven't done anything to actually make this neat or tidy yet. I wanted to just get the power supply up because I said before I couldn't see the wood for the trees. I couldn't really see anything that was going on in here. So I think now I've tidied it up, I've got a better appreciation. Now unfortunately our output valve, this 6F6, the whole base and a lot of the components have still been hacked round, and I haven't got round to sorting this out yet, but I'm starting to take a look at it. Now one thing that I have got on order, or in fact it's arrived, is, you know that we were missing the output transformer. Well, I've actually gone away and I've purchased a new output transformer from RS Components, which it's probably designed for a slightly smaller radio than this, but sometimes you have to do what you can. So this is one of those output transformers that's got multiple tappings on it, and depending how you connect it up, you can actually make it suit various single-ended anode loads. So I think the match for this 6F6 is around 7,000 ohms, so depending on what combinations of windings we can connect here, we should be able to connect between the 7,000 ohms of our valve anode to an 8 ohm speaker. Now I'm not sure how far I'm actually going to go with this radio. My thoughts are we kind of keep going with it until something terminal happens, which almost certainly will because it is in a bad way. But wouldn't it be nice if we could just hear this 1945 radio just make some sound out of its own speaker again? You know, I think that might be not a bad place to finish. So I think as soon as we've got the power supply actually up and running, what we'll do is we'll install this audio output transformer and we can see if this radio can make its own sound again. That'd be nice to see, I think. Now, having made all the modifications to the power supply, I've not actually powered it up and tested it yet because I wanted to have you guys on hand on Firewatch, you know, getting ready with the old bucket of sand in case something goes wrong. Tell you what, let's get a metering circuit so we can see what our HT is. Now in theory our HT is going to start to come up immediately because we've got this solid state rectifier in. Okay, I'm going to turn on the Variac now. Can you see that? Yeah, I think you can. Oh, well. Okay, that's 50 volts in. We've got 82 volts out. Okay, that's 150 volts in at the moment. So we're getting 250 volts DC out. Let's see what the wattage is. Okay, 10 watts, so we're doing okay so far. Just wondering if this, I'm just worried if this capacitor that I've restuffed is going to explode. It's actually quite a complicated capacitor, that. It was kind of difficult to wire all them things into the can, so there's every chance something's going to short out and go bang. Okay, we've got about 230 volts AC input. And we've got 375 volts of HT. I think this should be a lot higher than this. I'm sure it should be around 450 or maybe a bit higher, 460 for this radio. So we're definitely low on B+, but this is the transformer I've got, so we've got to go with it and give it a try, I'm afraid. Now last time we powered this up, it was actually this resistor here that was smoking badly. It was getting very, very hot, and well, I don't think it's smoking now anyway. It was almost starting to smoke immediately. So I think one side of this resistor, this is actually a smoothing resistor, so it's the main HT comes in on one side, and there's actually a smoothing capacitor which was still connected in the old smoothing can in here. So I think what had happened is the capacitor had probably gone short circuit, so there was a lot more current flowing into the capacitor there and shorting out than there was going in the rest of the radio circuit. So now I have gone and replaced the 10 microfarad smoothing capacitor there in the main can. I think that's cured our little overheating problem, or certainly nothing seems to be getting hot at the moment. Now the other thing I've done is I've also recommissioned the send and receive switch, which was previously disconnected. So in theory we can switch off the HT now, which we can do. I can just see the voltages come down, and we'll switch the HT back on again. I guess one of the questions we need to answer is, after all this hacking about, does this radio still receive something? Because it was receiving something previously. I wonder if it still will. So we've got no output valve in the radio, so we're going to have to use my little signal tracer here. Well, there's certainly a lot more mains hum there than I would like, a lot more.
Stepped up a bit. Madison has been playing phenomenal this season, and to be fair, he's been out as a bit of a blow. But listen, it looks like it's happening all over again.
It's certainly tuning better than it was previously, but I am a bit concerned with the amount of mains hum, but in some ways that's the least of our worries for now. It doesn't surprise me, just given the way that this radio is hacked around and all these long flying leads on everything. It could be coming from anywhere, this mains hum. These valve heater supplies have been really badly installed, so that might not be helping. Could just be a bad ground somewhere, could even be coming from a valve somewhere. So that was the resistor that was getting red hot before, and well, it's probably about 40 degrees now, so that's fine. The other one's running at about 40 degrees, so that's similar. So when it comes to buggering up radios, this is an absolute masterclass. You could learn a lot from this. Just shorting out that capacitor, making sure there isn't anything evil lurking on it. Because these capacitor testers definitely don't like it up them. Okay, well the capacitance good. It's coming up as 113 nanofarads, and it should be about 100. Should we just test it for leakage? Okay, so that capacitor's coming up as 1.8 megohm. I've actually seen much worse than that, but I'm going to have it out because it's not good. Now changing this one out isn't going to do anything for our mains hum problem, but it will please me to get rid of it because yeah, it's nasty. And I think while I'm in here, there's just so many components just snipped off here. If I was Mr. Carlson, I would spend several hours unpicking this tag here and pulling all the components off and rewiring it. Luckily for you, I'm not Mr. Carlson, and I'm just going to bodge on another capacitor. I do like to use a little bit of flux on whenever I'm soldering onto these old tags, because I think a lot of the tags are dirty, and well, you can see a lot of the dirt, it runs off in the form of like black tarry crud. I think it's worth using a bit of flux on some of these things. My opinion is it really helps cut through the oxidisation on the tag strip, and it does help you get a good joint, so that's why I use it. Okay, so I'm taking a look at the output valve, and I'm afraid it's a case of not being able to see the wood for the trees again. There's so many things, well, including a number of long dead spiders crystallised around the legs of this socket here. I think we're going to have to clean this up a little bit, remove some of the solder and bits of stray components that are hanging off, and really start again with it. Now I can see that we've got our cathode bypass resistor here. This is a green one, and I did go ahead and I connected that earlier. I see that they've actually got the cathode bypass connected to 0 volts via one of the heaters, which to me doesn't sound like the best idea if you're trying to reduce noise. And I can also see that the other side of the cathode bypass this does go back to a 33 microfarad capacitor, which is in that main smoothing can. So I did reinstate that a little bit earlier, but yeah, let's tidy this up a bit more because it's a mess. So I couldn't help noticing this Plessy 0.033 microfarad capacitor, and it's actually been placed in circuit. It's actually the capacitor bypass for the cathode resistor here, the AC bypass. And of course this should actually be quite a much bigger value. It should be a 33 microfarad, but for some reason somebody thought it was a good idea to replace that 33 microfarad with a 0.033 microfarad. So yeah, just another of those little things that you find along the way. So I'm afraid you missed it the first time, but snippy snip snip, bye bye. So I was just about ready to have a go at connecting up this audio output transformer which I purchased from RS Components. I've used these on a few previous projects. They cost about £15 and they seem to work quite well in my experience. So this has a number of different tappings depending on what speaker impedance you've got, and also depending on what the output impedance of your valve is. So yeah, quite useful little transformers and not too expensive. So I went ahead and I just connected this up, and I wanted to do an impedance measurement before I put it into circuit, and well, that's where it went horribly wrong. So after quite a bit of messing around, it appears that I traced the problem to this speaker. So I've got the signal generator connected. We've got 10 volts peak to peak going into this at the moment, around 1 kilohertz, and as you can hear, silence. We really should be hearing something now. We're not hearing anything. But if I actually just disconnect my test leads from this point, and you can actually see that there's some more clip-on points here where the actual windings go into the voice coil of the speaker. I've actually got some audio there. So I'm not sure which one of these internal connections is bad. Okay, well, we've just found that one. So it looks like this particular speaker connection here isn't working properly. So I'm not sure which end the fault's at. So there is a little extension wire which runs to this voice coil on here. So if I go there, we're okay. If we go to that tab there, it doesn't work. No, but the wire itself seems okay. So it looks like our problem is maybe just this solder connection here. Strange that, because I did actually go over it with a soldering iron. Let's remove the old solder from that, give the wire a scrape and resolder it, and see if we get our connection back. Well, it's still not great, is it? I think that maybe this terminal is riveted together, and it could be that we've got corrosion under the rivet. I think that's probably what the issue is. I think it's a riveted connection. Yeah, so the underlying terminal here is just very, very rusty. I suspect that's probably our problem. I think that this connection is actually, it's a riveted connection, so we've got maybe something was a bright metal, bright steel at one point with a brass rivet through it, and we've obviously got some corrosion between the actual brass rivet and this this tag strip which is riveted in place. So yeah, that's going to be our problem. Now hopefully that's fixed our problem. So I'm just taking a look at the data sheet for our transformer. So it says we've got primaries of 4k to 15k with 40 milliamps DC. Now I'm not exactly sure what the current will be through this transformer. I'll probably go and have a go at estimating it from measuring the cathode voltage across the cathode resistor. So that's something to actually check. I'm not sure if it gives, yeah, it says it's kind of rated for 3.5 watts. I seem to think this output valve might be rated for 10 watts, but I'm not exactly sure. I'll have to double check that for the 6F6. So I don't know if this transformer will be suitable, but I do intend to just give it a try, especially for just test purposes. If it looks like a winner, we can always find something a bit more suitable. What we have got to do though is to choose the right tappings. So I think that the recommended anode load for this 6F6 valve is about 7k, so there's a setting here, 6 to 7k into an 8 ohm speaker. So I think we'll just double check the impedance of the speaker, and then we'll probably go ahead and use that setting there. So 6 and 7. So looking at our transformer, that's telling us to use 1 and 4. So I'm going to put a little circle around there to remind me. 1 and 4. And what's the secondary? D and A. So it looks like we're using the N connections for both the primary and the secondary. Okay, well we were looking for 6k I think, and we're getting exactly 7k, so I'm going to call that. That's going to be good enough. I suspect the actual valve anode will actually see a lower impedance than that because of all the tone correction components in. I'm not sure, but I suspect that could be the case. So I'm going to measure the voltage across our cathode bypass resistor, because if I know the voltage across it, that's going to give me an idea of how much current is flowing through the valve. It's not going to be completely accurate because we'll also be getting the addition of some of the screen grid current as well. So it might not be a perfect reading, but I think my understanding is most of the current will be coming via the anode connection. Okay, so we've got 21 volts across there. In my head I seem to think that I should have had a figure of around 16 volts, but I'm not certain. Can't hear any noise whatsoever at the moment. I think what we'll do is we'll just turn off and we'll just do that calculation. So 21 volts. So we've got 21 volts across a 470 ohm cathode bypass resistor, which equals, yeah, that's quite a bit. That equals 44 milliamps. So I think the maximum current for this transformer is actually telling me it's about 40 milliamps DC. So we could actually be exceeding its nominal rating there. We could be.
We put ourselves in a very strong position. A win today, I think, would definitely take us, 1, 2, maybe 3 steps closer to doing it. But
so as I said earlier, this set does seem to be bringing in quite a lot of hum. There's a lot of reasons why it could be bringing hum. Anything to do with a bad valve, to probably more likely just really bad wiring of the valve heater supplies and stuff like that, or maybe incorrect bypassing of the valve heaters, because we don't know if any of that's been done correctly, because it isn't the right transformer, and certainly a lot of the wiring has been hacked around. One thing that can make a difference is I've noticed that you can get a lot more hum when you're actually running off an isolated supply. So just for the sake of discounting that, we'll just try swapping it over. So I'm going to go on to the other unisolated supply now. Well, that's a good sign because my RCD in my room hasn't tripped out, so it looks as though we haven't got any gross leakage to earth on here. But the hum is still there. The hum is also there when we actually turn the set down to absolutely minimum volume as well. Another thing that can make a difference is we could try actually reversing the live and neutral supply coming into the radio transformer here, because sometimes having it phased differently either makes it much more noisy or not. So we've got a lot of levers we can pull to try to track down the noise problems, but I've got to admit this kind of hum problem, I've always found it very, very difficult to try to track down. So again, if you've got some hints and tips for how to track down mains hum, leave it in the comments. I guess one of the first things we should probably do is actually just look for any ripple on the B plus on the supply lines. Could be that this mains choke is nowhere up to the job. I really don't know at this stage, but the radio is making sound. So
consistent, and they've played fantastic football. But I'm not worried about City the same way I was 2 years ago or 2.5 years ago. So with that in mind,
let's just have a bit of a tune through, see what we can pick up.
I need you tonight. can you find out the value of your current home before you...
30 unbeaten. We've conceded 6 goals around that, in that.
I think this radio's probably being overloaded by the strength of some of these incoming signals. I've got the RF gain turned fully down at the moment, and yet we've still got really a very high signal level.
We don't even know about that you'll be drilling into that Man City side, so I just think even if they were to...
Now I think because it's a relatively simple job, I'm going to go ahead and I'm just going to finish wiring in this this tone corrector circuit now, because it's out of circuit at the moment. It's partly wired at one end of the valve, but I think I will wire that in now because, well, it's just another job done, isn't it? So I'm going to go ahead and do that. Okay, well, we've now got a working tone control, so we're making little small steps. As you can see, I've been diligently avoiding here going anywhere near the waveband select switch, because this is probably where our main problem is. And I've been diligently managing to ignore it so far. Now I also went ahead and I did another little repair off camera, in that I found that last time we were using this, as we were actually tuning it and these vanes were actually meshing with each other, we found some spots where the radio made a crackle and then just went completely dead. Now that's actually what I would call quite a well-known fault, and you'll find that it's often being caused by these moving vanes here, these moving plates of aluminium here. What actually happens is, if they're slightly bent or misaligned, they'll actually short out against the fixed plates. Now I can also see, looking at these, when I actually look inside them, I can see corrosion inside them as well, which is probably not helping. But what will happen is, as you actually open and close, as you mesh and unmesh them, the set will go completely dead. Now that was especially the case with this radio, because what was happening is the actual local oscillator was being shorted out by these vanes here. So what I had to do is, I just use a meter on the bleep range, on the ohms bleep range, and what you'll find is, as you open and close the vanes, you'll hear your meter bleeping. Well, these should be, open circuit. They should be acting like a capacitor. So if they're shorting out the plates, you'll be able to see that on as the resistance drops across your meter. So what you want to do is, you want to take a small piece of wood, a toothpick or a piece of plastic. You don't want something made out of steel. You don't want something particularly sharp, and what you've got to do is, you've got to very lightly touch each of these fixed plates, and you'll find the one that's rubbing or catching. You'll find that as soon as you touch it, your meter will go bleep, and that's how you can identify it. Now once you've found the one that goes bleep, all you can really do is you can just actually bend it open a little bit, which is what I did. I prefer to do it with my fingers again, because I don't want to damage it. It doesn't take a lot of pressure, and it's the sort of job you need to do very, very carefully. Don't rush it, because if you just start bending these plates, you'll distort them, and they will short out forever. You'll make the problem worse. So just find the one that's causing the problem and just very gently tease it apart. Don't rush it. You might have to adjust it in a couple of places to actually get the result you want. And what you'll find is, if you just keep adjusting it and adjusting it, you'll find out that it shorts out in less and less places. So as you're actually making the adjustment, you want to be meshing and unmeshing it, just to make sure you're not making the problem any worse. So apparently our Hallicrafter is a 4-band receiver, so it's got 1, 2, 3, 4 bands. Now it says that the first band spans between 550 kHz and 1.7 kHz. I'm guessing that is a typo there. They actually mean 550 kHz to 1.7 MHz. So that's the first band. The second band spans between 1.7 and 5.4. The third band is between 5.3 and 15 MHz, and the fourth band is between 15.5 MHz and 44 MHz. So what I've done for each of these bands, I've effectively split the difference, and I found the mid-band section here, because what I'm going to do is, I've got my signal generator connected via a dummy antenna, and we're going to just squirt some signals into here. So first of all, we're going to squirt a signal in of about 1.16 MHz, and let's see if we can actually tune in. So we are able to tune into that signal, so that does mean that, yeah, that looks as though we are on the medium wave band, and we're injecting a signal there of about 20 microvolts, so a pretty big signal actually. So this radio receiver is of course very deaf at the moment, but really we wouldn't expect anything apart from that, given that it's been messed around with. It's got maybe those damage to those inductors and we haven't done any alignment on it. But yeah, certainly it's picking something up. I think probably the actual dial alignment will be quite a long way out. I suspect that it isn't actually tuning mid-band. I think all the frequencies are maybe shifted over to one side somewhat. So again, that would require some further investigation. It'd probably come right when we did the radio alignment maybe. So the next thing we've got to do is find band 2. So apparently I would now need to inject about 3.5 megahertz. So in theory I think that should be band 2 now. Okay, that's around 50 microvolts and we can just pull the signal out of the noise there. So it looks like we've got band 2 working as well. So let's have a go for band 3, which according to this we need 10.5 megahertz. So there's our band 3 and it's coming up in a similar place in the mesh of the variable capacitor as the other ones were. Okay, let's drop the level to 50 microvolts, that'll be the same as the others then. Actually, so this band is actually much more sensitive than the others. So band 3 appears to be working very well. Let's drop it again, 20. Okay, we're on 5 microvolts now. Let's try 2 microvolts. So just by ear, I think that this is about the same level of signal to noise as we were getting before. But before we're having to inject 50 microvolts, well, on this band we can hear about the same level for a 2 microvolt input signal. So band 3 certainly works very well, doesn't it? So the final band that we're going to try is band 4, which I'm guessing must be there. So band 4 between 15 and 44 megahertz. That does seem a little bit lower in sensitivity than the band 3, but it's still quite a lot better than band 1 and 2. Well, I think what we can see from this test is maybe the band select switch isn't perfect. It certainly feels horrible and it's crunchy, but it is actually working. It's working well enough that we can select between bands 4, 3, 2 and 1, or 1, 2, 3 and 4 for that matter. So it is working to a fashion, isn't it? It's certainly working well enough for us maybe to carry on with this radio. So I don't know, again, leave it in your comments. Do you want to see more of this radio? Shall we keep going with it? Shall we try to improve it, finish off the restoration maybe, do an alignment? Shall we see how good we can get it, or is it time for the bin? I don't know. Has it overstayed its welcome? The choice is yours, leave it in the comments, but for today I think that'll do. Thanks for watching, see you again very soon. Until then, bye bye for now.